You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hello, everybody. Welcome to the show. I know I am excited to be here.
So
How's
excited.
everybody else doing?
Great to be here with you.
Doing amazing.
This is kind of fun. This is the final show of 2025. This is coming out New Year's Eve.
We really couldn't cut it closer.
If you are listening on New Year's Eve, you are a dedicated fan. And
Love
we
it.
appreciate you deeply. No, absolutely. No, there's what better way to spend the end of the year than with a show you love and enjoy. And I assume you do love and enjoy it because you are here listening. I will say, we do want to show some appreciation too to all of our wonderful patrons that supported us over 2025 and literally made this show possible. As we're rounding out the year, if any of you are listening and you're like, you know what? I listened to this show a lot this year in 2025. If you want to show your appreciation and become a member of the Society of Strange and support the show and get ad-free episodes, check us out over at patreon.com. We're at patreon.com/strange by nature podcast. Cool way to either end up the year by becoming a patron of the show, or maybe to kick off 2026 and treat yourself to a commercial-free lifestyle by becoming part of the Society of Strange and getting those commercial-free episodes, and also some of the bonus content too at certain levels of being a member. So just a little plug for that, you guys.
And a fun sticker.
If you join at one of I think the second or third tier, you get a sticker as well. So we appreciate everyone. And whether you can support the show either by, listening to the ads or by becoming a patron, we do this for all of you. And we really appreciate you. And it's a good time of the year just to think about that. So we wanted to say thanks.
Thank you, everybody.
You. And if you aren't in a place where you can do any of that, tell your friends. Have them listen to the podcast. We
spread us like a virus. A
that
highly
might be too soon, Kirk.
Contagious virus. No. Big social gatherings are back in. Go to a party, tell everyone. Because here's what happens. Can we have a little moment here just between you and me, listener? I know how this works, right? You're listening on the way to work. You hear some cool little fact and you're like, oh, I'm totally going to share this with everyone at lunch because this is so crazy. This thing I learned. Look, that's cool. I love that. Use us that way. That's why we're here.
Absolutely, it is.
You'll notice at the end of our segments, we always try to, cite our sources. We just ask you to do the same. Tell your friends where you're getting all this cool info. Let them in us. Don't keep us a secret. Let your friends know about this show because having us grow actually allows us to do more fun stuff with the show and improve the quality. And the more you share, the more you care. Sharing is caring.
Sharing is caring.
Except in diseases.
All right.
Well, you make a good point, Rachel.
I can't disagree.
Anyway.
Wow. How about we are the cure to boredom, share the cure.
Ooh.
Oh, that's a good one.
I like that.
Right.
That's fun.
Put it on a t-shirt. Here we come. I want to talk this week. I'm going to share because I get to go first this week. And I've got a story to round out the year here. As I think about when it comes to nature, which obviously we talk about here on the show. One of the things I love,
wild concept.
Shocking. One of the things that I love to teach people about, and I don't know if you had a similar experience, but I love to teach about how evolution has found more than one solution to the same problem. Because I just find that utterly fascinating.
It really
There are basic things that living things need, like say energy, and that's true for plants, fungi, animals, and in those three groups right there, those groups have all found different ways to get energy, for example. Like a plant makes their own energy, whereas animals eat the plants to steal energy. Or some animals might even eat other animals to get their energy. And we see these different solutions when it comes to vision and hearing, mating, sleeping, aging, healing, thermal regulation, camouflage. Basically, everything. There's a lot of these basic needs that animals and even some plants, have and have found either the same solutions or just completely different solutions to these problems. And I always find that utterly fascinating. It's those differences actually that are part of what defines one species from another, right? Are those adaptations, those differences, which are responses to their environment. And our shared systems, the things we all have in common, I think are really fascinating. But a lot of times the differences are even more fascinating and fun. I do think as humans, we sometimes can fall into this trap. And we've talked about this in the show before, I think, of like assuming that the way our bodies work is the default and that everything else is strange.
Right.
And to be clear, if we didn't think like that, then this podcast wouldn't exist. So thank you.
So true.
We deeply appreciate that you all think that way. We appreciate that you appreciate strangeness. But one of the things I know I talk to groups about a lot is hearing. And that's because I frequently have to teach, or I say have to, I have the great honor to teach with a live great horned owl on my arm.
Yes.
And this is the great Regina, or Reggie the owl. She is one of my coworkers. She's fabulous. But
She's
her
a big
ears,
bird.
she's a big bird. Yeah. Her ears are slightly different than ours. Like many owls, she has this unique asymmetrical placement of her ears, and owl ears are often asymmetrical, which allows them to judge whether a sound came from above or below them, which is something humans are not particularly good at. We're good left, right, not so good up and down.
Right.
A lot of owls can basically target prey in the dark using just their hyper accurate ears. I know barn owls in particular are very good at that. And the other thing that I mostly talk about, with groups though, is that they don't use this weird flap of skin and cartilage on their heads to direct sound waves into their ears.
Right.
They use a facial disc of feathers to help direct sound into their ear holes. So I love teaching about that because like their actual inner ear works essentially the same as ours. They have an eardrum that picks up vibrations, transfers it to the inner ear where little hairs connected to nerves in the cochlea pick up those vibrations and send electrical signals to the brains, what's then decoded into sound, etc. Like that's the same way that our ears work. The owl just collects the sound waves in a different way, but their inner ear is roughly comparable. So the differences, again, are what makes that super cool. But what if you needed to come up with a completely different way of hearing and you could not use an ear of any kind?
Huh. Okay.
That would be really different, right?
Is that what you're talking about today?
Oh boy.
That is what I'm talking about today, yeah.
Oh, man.
So Rachel looks like she's already broken. So this is an example you're both completely familiar with, and as soon as I say it, everyone in the audience will be like, "Oh, of course."
Right. Well, I mean, you say this, but like Victoria just talked about animals hunting without eyes.
Yeah, crazy, right?
Yeah.
This is not quite that crazy. I'm talking about insects, right?
Oh, right.
Oh, duh.
So I know, right? I said as soon as I say it, you'll be like, "Oh, no, okay, duh, yeah, of course they don't have
Ear
ears
holes.
like we do." But if you think about crickets and cicadas, we can hear them communicate to each other with sound all the time. So clearly they have some way of hearing those sounds. Some insects actually have a kind of like an eardrum. It's a thin section of their exoskeleton that vibrates to sound waves. But I want to talk about something even stranger and different than that, because that's a little bit too analogous to humans for me. Some insects hear with antennae.
Oh,
right?
Actually, you're starting on this topic, Kirk, and I realized I don't really know anything about insect hearing, so I'm going to learn
Excellent.
something.
Yeah.
Excellent. Well, an antenna is an amazing tool that insects have that allow them to sense their world in multiple ways. But I want to laser focus in on the tiny fruit fly this week. Those little things that end up the Drosophila, the things that end up in your house when you leave fruit out.
You
I have
use
to
apple
set a
cider
little.
vinegar.
Yes.
Yeah.
I found actually wine is even more effective.
Ooh.
Yeah.
Actually, if you want to catch them, you use old wine. You use vinegar, and vinegar is an effective trap.
Yeah.
Right.
I've used
'cause
vinegar, and I found that wine, like actual wine, works even better.
That's just a waste of wine.
Well, I suppose. If you have an old bottle, though, that's like...
You have an old bottle sitting around, which is essentially turned into
Vinegar.
It hasn't quite turned into vinegar yet, but you don't want to drink it anymore.
Right, same idea. Yeah, they're definitely attracted to those smells there. So these fruit flies, they have antennae on their face that we know are used to pick up sounds. And we know this because researchers, going back to the 1960s, have done experiments where they would clip the antennae of female fruit flies.
That's so mean.
And I know, it's kind of mean, but what they found is that, we're saying it's so mean as we're just talking about ways to kill them in our house.
Right.
Okay. Ways to drown them
There's
in wine.
levels.
And there's worse ways to go, I suppose. But what they found is that the female fruit flies then ignored the mating songs of the males. And you might be going,
Who
wait,
knew?
The mating songs? Yes, my friends. Male fruit flies woo females with songs, but don't get too excited. They aren't really singing. It's more like playing an instrument. They make sounds with their wings to attract a mate. And when they would, clip these antennae of the female, they'd kind of lose all interest in the males because they basically couldn't hear them anymore. So we know they can hear with these antennae, but we didn't really know how. I think the assumption was that the sound is basically just vibrations in the air, right?
Yes.
So if the air is these pressure waves in the air or these vibrations in the air, the antenna are out in the air and they're going to vibrate along with the air, and the fly can just feel those vibrations, right?
Right.
But that's kind of vague, right? I mean, if you know that something like that is happening, it's like, but what's the mechanism? That's like saying, oh, sound goes in our ear holes and then we can hear. You're like, well, yeah, but there's more to it than that.
Yeah.
It's not that simple, right? Now, I did say that we were going to laser focus on the fruit fly, and I meant that literally, because back in 2001, a team of researchers at the University of Zurich in Switzerland found a way to use a laser to measure nanoscale vibrations of fruit fly antennae.
Wow.
Now, these antennae are very small. They're about 300 microns long, which is actually longer than I thought they would be. But just to make sure we're all on the same page here, a micron is 1/1000th of a millimeter.
Yep.
Or 1/millionth of a meter. So 500 microns would be half a millimeter. So pretty small.
Visible to the naked eye, but
yes,
barely.
but barely. And especially these are also very thin, so maybe not visible.
Okay.
You know what I mean?
Fair.
But like theoretically, yes, a dot that size, you'd be able to see that. Human hair, we can see human hair, for example. Human hair varies in thickness, but a relatively thick human hair, that if you know a friend who has like thick hair, that's about 100 microns wide. So these antennae are like 300 long. So 3 hairs thick or so.
Mm-hmm.
Yeah.
We're talking about small stuff.
Yeah.
So these researchers were studying not just how these tiny antennae vibrate, but they wanted to look down at the base where they interact with the body to figure out how they actually work. And so they were looking at stuff much smaller than the actual antennae itself. They're looking at this extreme close-up here. It was basically a laser microscope type device. So this was pretty new tech back in 2001, which, mind blower, that was 24 years ago, which makes no sense to me. But
don't think about it too hard. Don't think about it.
Yeah, we hadn't actually had the tools to study things this small in the past in terms of how they vibrate. And so they were like very excited to test this out. Mm-hmm. Now, these antennae essentially come out of a structure that is the fly's nose or their olfactory organ. So imagine if humans were hearing our world with really long versions of nose hairs that stuck out of our face and picked up vibrations.
Sounds uncomfortable.
Very, very weird. I mean, if you were sneezing, it'd be horrible. The sound would be awful. But, obviously flies don't sneeze, so it's a separate situation. But I just love the idea of like these giant nose hairs, frilly nose hairs sticking out. And people are like, oh, I can hear you. Yes, I'm pointing my nose at you. Well,
there it is.
So it turns out that we were wrong in our assumptions. These antennae aren't just vibrating and picking up sounds. They're actually rotating.
Oh.
Which breaks my brain. So vibrations cause the antennae and their base to actually rotate. And then there's a little hook on the end that like stimulates nerves as it rotates.
Oh my gosh.
And it almost reminds me more of how like a record player works, but like more like when they were recording the record, like when they're recording sounds on a spinning disc rather than when you play them back. The researchers didn't use that metaphor. They described it more like turning a key in a lock. So like the vibrations are making it rotate back and forth, and that rotational energy is being transferred into sound.
How bizarre.
That's wild.
These flies have essentially rotating noses. It's just like, what?
Okay.
Like so weird.
Here's a question I have though, Kirk.
Yeah, I may not be able to answer it. I'll try.
So with an internal ear, the way that vertebrates have, I mean, obviously we have the external part of it here, but the of our ear, but the business part is inside your skull.
Yeah.
And it's protected. So like stuff that gets in there is going to be sound waves. But if you have like hairs that are sticking out on your face,
everything.
Like how is
probably important to think about, like, and this is something that the researchers, as far as I know, didn't really go into, but like if you think about, sound and like the frequency of sounds they're looking at are extremely small. So like, can they even hear? Like, what is the frequency range they can hear? Like, can they hear the wind? Like, I'm thinking like the wind is blowing across there, but is it so small that like it's not even affected by the wind because the wind is like blowing at a lower frequency type or something like that? Like, I don't know how, because really the only thing that's going to be messing around with it is probably going to be like the wind. Although I'm going to touch my microphone here, like, if they're rubbing against surfaces, they're probably hearing something, like that. I couldn't hear that. I'm sure audience is like, oh my God, that was an awful noise. But like, I'm sure, antennae are also sensory organs, right? That are used for touching and exploring things. So it could be that as they are exploring their world through touch, they're also hearing what they're touching and not just feeling what they're touching with the antenna. So, I mean, it's wild. It's so different from our experience, right? That it's hard for us to really imagine like hearing the things we're touching. Like, I mean, we can sometimes do that, right? But it's not like an integral part of when I'm touching my blue jeans right now. I'm not like hearing that, and that's not an important part of my sensory experience. So really interesting.
Yes.
But it's interesting because it's so strange and so different than how it works for us. These two researchers, actually, Robert and Gopfert, went on to discover that other species of flies also have these strange rotating antennae that pick up sounds. So it's not just fruit flies. There's other species of flies that have this as well, which is just so cool to think that these animals are out there doing their thing and it's so different from us.
Yeah, that's wild.
But like, that's basically what I have for you this week. It's another case of animals doing the same thing we do, but in a totally unique way that's completely different than how we do it. It works for them, though. So I, for one, am grateful. I don't hear using giant rotating nose hairs that stick out from my face. But I guess if we all did, it would seem normal, right? So my sources this week were the journal article in Nature, which is called "Turning the Key on Drosophila Audition." Clever title there. And then also there was a article on Science News kind of summarizing that as well, called "Fruit Flies Hear by Spinning Their Noses." So you can check out either of those if you want more information.
Wild, honestly.
Very cool. Well, I will take us into a break here, and when we come back, we got something from Rachel.
All right, welcome back to the show, everyone. So recently we've talked a lot about bats.
Yes, I have talked a lot about bats.
Yeah, it has come up. I think ever since Halloween, there's been bats in the air.
Well, they should be in the air. That's what
they do.
A bat. But we've also talked about their predators. And my topic this week still talks about bats. Sort of.
Okay.
All right. Sort of. Okay, stay with me.
We
know, since we've talked about it on the show, not even just recently, but throughout the entire genre of the show. I think the first time we talked about bats was vampire bats in like episode 35 or something
of course,
like that.
Yeah.
Yes.
Bats are strange in and of themselves, just because they are winged mammals. They're true flying mammals. They're one of the only mammals that actually fly, which is already wild. And the fact that they use echolocation to find prey is also pretty strange, especially for like a land-based animal versus like the echolocation that dolphins use.
Sure.
They're using it in the air. There's a lot more.
Oh, bats are. Yes.
Bats are. Bats are. Dolphins are very
It's
much
those
using
flying
it
dolphins,
in the water.
If there's flying dolphins, you'll hear about it here first.
Woohoo! I have a different topic about dolphins that I've been sitting on, actually. Anyway, but, you know, as bats are using echolocation, pretty much how it works is, and we've talked about this too, but to give a little bit of an overview, bats, what they'll do is they'll send out a sound out into the air. It's a very high-pitched sound. It goes out, and then it bounces off of something, and that creates a frequency. Now, that frequency allows the sound to, like, depending on what it hits, it tells the bat maybe that it's a tree or an insect or another bat or something else in its way, because they don't have great eyesight, partially because they're nocturnal. And that gives the bats an overview of what is going on in their surroundings and help them find prey.
Yeah, it's like the reflected sound waves that they're hearing, right?
Exactly. Now, so obviously, if you have a bat, you are a bat. You are going forward and you are trying your best to eat as much as you possibly can, because that allows you to, survive.
Survive, yeah.
Yeah, flying is very energetically intensive activity.
Exactly. On the flip side, if you are, say, a moth, you don't want to be caught by a bat.
You do not.
Correct.
Because if you get caught by a bat, you die, pretty much.
Night.
You are being eaten.
Yeah, getting eaten is usually synonymous with dying. I'm uncomfortable. I'm comfortable with that. Yeah. Oh,
good. I'm so glad. So you don't want to be eaten by a bat. So there are multiple ways that moths they're kind of we've talked about this a couple different times. They're in a evolutionary arms race. So on the show, we've talked about evolutionary arms race in a couple different fashions. We've talked about it with pronghorn. We've talked about it with a variety of other creatures. Kirk, you kind of mentioned it in your segment. And that in and of itself is pretty important. Moths don't want to be eaten. So as the moths that don't get eaten reproduce, they have new strategies potentially that are coming up over time.
Mm-hmm.
Now, some of those strategies include being able to hear, and being able to hear whether or not like a bat is coming, and having really sensitive hearing.
Well, this is an interesting correspondence of your topic with Kirk's.
Yeah.
Isn't it? Now, here's the thing. Eared moths can detect the echolocation calls. So they can hear the call that the echolocation has sent out and tell that a bat is on its way and where.
Yeah, it's like being in a submarine and hearing that sonar ping and being like, oh, we've been made.
Run! But what if you are an earless moth?
Right.
Ooh.
Because there are earless moths out there. So they need to, in order to survive.
I'm sorry, is that a scientific term? Like the earless moths? Okay.
Yeah.
All right.
So there's like two different groups of moths. There's eared moths and then there's earless moths.
Gotcha.
It's a thing.
It's a thing, yeah.
Okay.
It's a thing.
It's a whole thing, you guys.
Uh-huh. So earless moths, they have to still be able to defend themselves against bats.
Sure.
Yeah.
Well, they actually have many, and this is mostly silk moths. They have developed a method of absorbing the sound with their scales.
That is so awesome.
So cool. So they're like a black pit of echolocation.
Exactly.
Yeah.
So it literally allows them to be able to like absorb some of the sound. Okay. And that makes them literally disappear. Okay.
Awesome.
So that's one, but that's not what I'm talking about today.
Mm-hmm.
Oh, okay.
Because there are other earless moths, like the ermine moths. And what they do is they actually create their own ultrasonic signal that jams the sonar of the bat.
Awesome. So awesome. Yeah.
That's so cool.
It's absolutely wild. So what is going on here, right? So they're trying to protect themselves from the bats so they don't get eaten. These little moths, which cannot hear, they're not able to hear, they're able to create this. They have a little structure in their hind wings. So this is in their wings, not in their legs or any other part of their body. And they are able to create, when an echolocation signal comes in, they are able to like, the sound, when they are flapping their wings, they are producing a counter sound that allows them to like jam the echolocation.
That's just completely, I was going to say bat something, but that's, try to keep it PG. That's crazy. Let's put it that way.
Yeah. So most of moths, a characteristic of moths, try saying that 10 times fast. Moths are fuzzy, right? When you look at like them compared to butterflies, in reality, all butterflies are moths and not all moths are butterflies. They are fuzzy, right? They have really fuzzy antennae. They have fuzzy bodies. They have kind of fuzzy wings. These moths actually have a small patch that is clear and has a structure of like ridges and valleys. And that sound that they are able to create with that ridge and valley system is tuned to confuse bats. So it's absolutely wild. It's known as the aeroelastic timbal.
Are they making that sound at all times then? Or is this something that actually is reflecting the incoming sounds of that frequency?
So while the moth is flying, every single time the moth's wing, the ridges snap one after another.
It's a constant jamming
jamming signal.
Okay. That's what I thought.
And then, so it's known as an aeroelastic timbal, and it actually like vibrates and amplifies the volume of that sound. So it makes kind of like a clicking sound, which you can actually detect using like, so we'll use sound technology to be able to determine different bat species, like our own type of sonar. They can hear the moths with that technology as well, making the sound.
Yeah, one of the places I worked, we used to have one of these devices. They're actually not terribly complex to build your own. You can get them as kits and stuff online, but it's little, essentially a microphone, an ultrasonic microphone, and then a little chip that just takes the frequency and like divides it in half, or like makes it a lower frequency. So it's a little speaker, you turn it on, and every time it picks up an ultrasonic sound, it just turns it into like a tick, 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 tick. And you can hear bats flying overhead. And it also picks up the sound of grass, like rubbing against itself. And sometimes you'll be like, oh, it's a bat. And it's like, no, that's just the grass blowing against itself. So there's a lot of sounds to that frequency that we just don't normally hear.
Right. Absolutely. And it's just really fascinating because it does confuse the bats, so it protects the moths from being eaten in the first place. But this particular mechanism is something that is also called, it's called a snap through. So it's in engineering terms, it's a buckling instability. So like it's a structure in the way that it works with the ridges and the valleys, it loses, it just snaps into like a different state.
Sure, yeah.
When it's
little popping sound
that little popping sound is snapping into a different state.
Okay.
And eventually it will lose like stiffness and or collapse. But it doesn't seem to be happening for the moths. It seems to be like they seem to continue to be able to retain that stiffness. So a lot of sound scientists as well as like engineers are actually looking at these structures so that way they can use them to help design like aircraft wings, to help design sound absorbing materials and things.
Sure.
It's really interesting. Just what, because you're looking at this little tiny moth, we're able to then use that into bioengineering, and we use this all the time of making things that to look like nature. Like that's why we have airplane wings in the shapes that we do, because they're based off of different birds.
Yeah. Yes.
Exactly. This is another biomimicry moment that we get to have, and it's literally on the cutting edge. It's super phenomenal. I just thought that this was really fascinating that these little moths are not only evading bats, but they're doing it without being able to hear at all.
Huh.
Very cool.
Amazing.
Yeah. So my sources this week are an article in it's something called The Conversation in 2024 by Mark Holderride, Alberta Piera, and Rainier Groh. I also had an article from New Scientist, the Royal Society Publishing in 2020 also had a really great research article, Thoracic Scales of Moths as a Stealth Coating Against Bat Biosonar by Thomas Neal et al. And that was done in 2020. And then, of course, our favorite journal.
Oh, yes.
Proceedings of the National Academy of Science.
Of
Moth
course.
Wings are acoustic metamaterials by Thomas R. Neal et al. And that was
Very
also
cool.
published in 2020. So we're going to take a quick break, and when we return, it'll be Victoria.
Hey, we're back. All right. Well, I did not apparently get the memo. My topic this week is not have anything to do with insect hearing.
What?
That's okay.
It's so fun when things line up like that,
Yes.
but yeah, certainly not planned.
I did get a little nervous earlier. It was like, where is he going with this?
Yeah. All right. So, pop quiz time. What is the world's smallest animal?
Ooh.
Ooh.
A tardigrade?
Smaller. I mean,
Smaller.
when you get down to animal, like, are we considering like protists and things animals?
Like solidly
Probably
within
not.
the kingdom Animalia.
Yeah, it's got to be an Animalia.
Okay.
It's got to be microscopic. I couldn't tell you what it is though.
I'm going with the water bear or the nematode, or no, not the nematode, tardigrade.
Well,
I mean,
hate to tell you,
small.
Rachel, but you're wrong.
I
is
figured
smaller.
I would be.
Kirk is correct.
Tardigrades are also small.
It's true. But the world's smallest animal or group of animals, they're called the Myxozoans.
okay.
And actually, your question was pretty apt, Kirk, because for a long time, they're so small that they were for a long time mistaken for protists.
Okay.
They were thought to be single-celled, although they're not actually. They're only a few cells. They're tiny parasites.
Oh.
They're tiny parasites, and depending on the species, they can be as small as 20 microns, which, as we discussed earlier in the episode,
so tiny.
That's
wow.
2/100ths of a millimeter.
Oh.
Okay. small.
Yes.
That's, oh my God. I can't even like picture that in my head, how small that is.
Right. Yes. Well, okay, get ready. They're actually cnidarians, however you pronounce that. They are related to jellyfish.
What?
They're related to, yes.
Oh.
They're what?
Okay.
This was only confirmed in 2007, which, was 18 years ago now, but still seems pretty recent.
Still relatively recent.
However, they diverged from the jellyfish about 600 million years ago.
A little bit of time.
So just for a little bit of context, that's significantly before plants appeared on land, about 460 million years ago.
So long ago.
And
Jesus.
Needless to say, they have evolved in a drastically different direction than other members of the cnidarian phylum.
Sure.
Mm-hmm.
So, unlike the jellyfish type of common ancestor that they evolved from, they are tiny obligate parasites. They consist of only a few cells. And in fact, as I mentioned, they were mistaken for single-celled protozoans for quite a while. The thing that first clued in researchers to the fact that they are actually cnidarians is that they have kept a version of the stinging cell that's a defining characteristic of that phylum.
Whoa.
Yeah.
And
that's
nuts. What gives jellyfish their sting. They have these stinging cells. And these tiny parasites have evolved to use that to attach to their hosts.
Oh. So So that makes me wonder, like, was that its original use then? And you know what I mean?
Yeah,
like,
I don't know.
Yeah.
Because it means we know structures change function over time.
Yes.
And that's kind of how everything comes about. So that's the same structure essentially, but it totally different use. That's kind of stuff fascinates me.
Right?
Yes. Yeah. Obviously.
Yeah.
But like maybe one is the original, you know what I mean? Like that's or similar to it. That stuff fascinates me.
There are over 3,000 species of Myxozoans that have been cataloged, but taxonomists have estimated that there may be an additional 30,000 undiscovered species. As it is, they already make up about 20% of known cnidarian species.
I suppose when things are so small, it's kind of like what are the little diatoms? It's like there's so many. If you go and look in the pond down the street from your house, you will likely discover a new species of diatom just because no one's ever looked in that pond.
Yeah.
Correct.
There's so many out there.
It's incredible. The mind starts to boggle when you think about these things. You know, these Myxozoans, they're pretty wild. Most of them live in aquatic species, both fresh and salt water. And, if you look at a general definition of phylum Cnidaria, it says that they're aquatic, which is mostly true.
Sure.
So similar to many parasites, most of them have a complex life cycle. It often involves two hosts, like a definitive host, which is often, although not always, an annelid worm or a bryozoan. They also have intermediate hosts,
makes sense,
which is typically a fish, but not always. They have also been found infecting various species of amphibians, turtles, and water birds.
Okay.
Which, kind of makes sense.
If it's available,
aquatic animals or partially aquatic. Well, it also turns out that these little parasites have been found in the bodies of terrestrial mammals.
Oh, okay. All right. You've lost me. I'm out.
No, I get it.
I understand. Like deer,
specifically
like squirrels, the raccoons,
the liver and bile ducts of shrews that were found in a Polish forest.
Okay.
I didn't see shrews coming. Do these shrews live near water, though? Is that how this is happening?
Or something that spends time.
No, I was thinking something that hunts near the water and might be eating, say, snails out of the water, and then because we see that with we definitely see that you have things like liver flukes and stuff that spend part of the time in the water and part of the time on animals in the land. But do we know how they're getting it?
They could be there. It's hard to say because mostly people haven't looked for them.
Exactly.
And they're very small, so they're easy to miss.
Yeah.
That makes sense.
It's safe to say that they are extremely widely distributed and infect a very wide range of organisms. However, particular species of Myxozoan are usually very specialized to particular hosts and even to particular internal organs within the host.
Mm-hmm.
And so you can just, as I said, the mind boggles. Like, you can think about the incredible diversity that's out there. Some of them cause severe disease, but some of them seem to really not do much. So it's even easier to overlook those ones.
Yeah.
Yeah. Oh my gosh.
Sometimes it's smart not to cause disease, right? Because you just you can spread and go unnoticed.
Hang out. Besides being extremely small and being a jellyfish descendant that can live inside terrestrial mammals.
This is so weird. This is so weird, Victoria.
Why not? Sure.
Several other bizarre things about them. They have lost many features and many genes that other animals need, including genes for things like a mouth, a gut, or tentacles that all other cnidarians have.
These all feel like important things to have, though.
Yeah.
But if you're a parasite...
Yeah, if you're a parasite with just a few cells, you might not need them. So they don't have genes for multicellular development and coordination.
Sure, why not?
They are missing genes for cell-to-cell communication.
Okay.
Well, if you only got a couple, maybe it's not important, right?
Okay, hang on. Hold on to your hats.
Oh,
Some have even lost genes for aerobic respiration. That is the process of using oxygen to burn fuel in the body, which was something that we thought all animals and plants did until the discovery of one particular species of Myxozoan. Hennegaia salminicola is a Myxozoan that infects salmon and trout. And in 2020, it was discovered that they lack mitochondria.
What?
Yes.
No.
Yes.
Oh,
That's
the powerhouse of the cell.
The powerhouse of the cell, yes. Those are the organelles.
Literally the powerhouse of the cell. How could
Victoria, here you go. You officially tied into my topic now, because I started off talking about how one of the things all animals need is energy. So that brings up the question, Victoria, where are they getting their energy?
They use anaerobic respiration, which is something that all animal and plant cells can do, but it's not generally considered the most efficient way of creating energy and has some costs.
Usually,
just to back up, in case you don't know what a mitochondria is, a mitochondrion, those are...
Oh boy, how much time you got?
Organelles within, we've talked about them on the show before, but they're organelles within every living cell, we thought.
Eukaryotic life.
Eukaryotic life that converts fuel into energy, basically. So
we do say this often in the show. Nature laughs at our little boxes.
Yes. So animals...
Mitochondria are aliens living inside us.
Yes, they are.
Correct.
So most animals are able to rely on anaerobic respiration in a pinch, situations where there's low oxygen. Even we do it, if we're out on a sprint or something. But it's, as I said, it's not an efficient way to produce energy, and it can be hard on the body if it's done for too long. Not for this parasite, though. Just uses it all the time.
That's how it does it.
So
because of the way it is.
This is the first animal confirmed to have no mitochondria, although there is another completely unrelated animal from a little-known group that I had never heard of called Loricifera that live in oxygen-free deep-sea sediments and also appear to have no mitochondria, but it has not yet been confirmed.
Oh my gosh.
So if you are an animal that used to have mitochondria and presumably had it and then has sort of lost it and doesn't have it anymore, you're not considered a eukaryote, or you're not, it's not eukaryotic life. So
I think
it is though.
Grandfathered in.
That's why I was wondering, did you get grandfathered in? Because you're not a protist, are you saying?
Yeah.
Which would be the other group, prokaryotes. This is, again, as Rachel said, right in that line of like nature laughs at our little boxes. We think we got it all figured out, and nature's like, hold my beer.
Psych! Yep. No, you don't.
Yeah, so I heard about these strange little creatures, and I just had to share them.
Oh my God.
My sources this week, I had several. There's an article in Live Science, What is the Smallest Animal on Earth? The World Register of Marine Species, delightfully acronymed WORMS, had a great article about Myxozoa. Genomic Insights into the Evolutionary Origin of Myxozoa within Cnidaria in our favorite journal, Proceedings of the National Academy of Sciences.
There it is.
An article from The New Scientist, an animal that doesn't need oxygen to survive, and got a little background information from Wikipedia. And yes, that is what I have to share this week, and that brings us to the end of our show.
Thank you.
Absolutely wild.
What a way to end 2025.
With the world's smallest animal that doesn't even have a mitochondria.
That we found yet.
Well, I'm excited to see what next year brings, and I hope everybody will come along on the journey with us.
Yes, indeed.
Fingers crossed.
Happy New Year, everybody.
Happy New Year. Bye.
Have a good night.
Bye.
Bye.
Thanks, everyone, for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.